Welcome to this exciting video where we will take you on a journey to explore one of the most advanced and controversial scientific techniques, cloud seeding. Have you ever imagined that humans are now capable of forcing clouds to rain and even turning them into snow? How does this scientific magic happen? And how can countries like China control the weather with such precision? Stay with us to learn all the details. To understand how cloud seeding works, we first need to understand how rain forms naturally. The process begins when water evaporates from seas, rivers, or even plants, rising into the atmosphere as water vapor. As this vapor rises to the higher layers of the atmosphere where it is cooler, it begins to condense around tiny particles like dust or salts suspended in the air, forming very small water droplets. These droplets gather together to form clouds, and over time, as the condensation process continues, the droplets grow until they become heavy enough to fall to the ground as rain. If the temperature is low enough, the water droplets freeze to form snow or hail. But what if the natural conditions aren't ideal for rain to fall? This is where cloud seeding comes in, a technique used by countries like China to encourage clouds to rain even if they aren't fully ready for it. The process starts by selecting the right cloud, as not all clouds are capable of producing rain even if they look large and imposing. Therefore, teams of scientists rely on advanced techniques like satellites, weather radars, and planes equipped with special sensors to measure the temperature of clouds, humidity levels, and the concentration of water vapor inside them. After identifying the suitable cloud, the execution phase begins, and this is where planes and rockets come into play. When planes are used, they are equipped with special systems to spray seeding materials like silver iodide or dry ice. Inside the plane, there are tanks containing these materials connected to pipes and fine spray nozzles. When the plane reaches the appropriate altitude inside the cloud, the pilot activates the system and the material begins to exit in the form of a fine mist that quickly spreads inside the cloud. However, the material is not sprayed randomly, but rather targets specific areas inside the cloud known as growth zones, where upward air currents are strong, which helps distribute the material as efficiently as possible throughout the cloud. In some cases, instead of planes, rockets are launched from the ground, carrying the same seeding materials and exploding inside the cloud, spreading the material more widely. But what happens inside the cloud after spraying silver iodide or dry ice? This is where the most important phase begins. Silver iodide is molecularly similar to ice crystals, so when it is sprayed into the cloud, it acts as a condensation nucleus, meaning it attracts surrounding water vapor molecules. When water vapor adheres to silver iodide particles, it starts to condense around them, forming very tiny water droplets. Over time, these droplets continue to grow through a process known as condensation and collision, where smaller droplets combine with each other until they become heavy enough to fall to the ground as rain. If the temperature inside the cloud is very low, below freezing, the water vapor doesn't turn into water droplets, but instead freezes directly around the silver iodide particles, forming snow crystals. These crystals continue to grow until they become large and heavy enough to fall to the ground as snow. Dry ice, solid carbon dioxide, works a bit differently. When it is sprayed into the cloud, it quickly lowers its temperature, causing the existing water droplets to freeze immediately, turning them into snow crystals. This means that dry ice can be used more efficiently in colder areas, where it helps accelerate the snow formation process directly. But is everything perfect in this process? Of course not. There are many downsides and concerns surrounding the technique of cloud seeding. First, the materials used, like silver iodide, can accumulate in the environment and may have unknown effects on soil, water, and living organisms. Second, there is debate about whether cloud seeding may lead to the theft of rain from other areas, as forcing clouds to rain in one place may reduce the amount of rain that would naturally fall elsewhere. Third, there is a risk of unexpected floods if cloud seeding is carried out excessively or at the wrong time. But one of the most interesting questions is, how does China or any other country determine the right amount of silver iodide to spray into the cloud? The answer relies on precise data collected before and during the process. Scientists study the cloud's density, the amount of water vapor inside it, and its temperature, then calculate the ideal amount of seeding material that the cloud needs to begin the condensation process. Very small doses are used because overuse can lead to counterproductive results, such as producing droplets that are too small to fall as rain. Cloud seeding is one of the most controversial scientific developments, as it represents humanity's ability to intervene in one of nature's greatest phenomena, but it also raises serious questions about its impact on the environment and the future of the global climate. Are we really entering a new era where humans control the rain? Share your thoughts with us in the comments. Do you think cloud seeding is a smart solution to drought problems, or could it cause bigger issues in the future? Don't forget to like and subscribe to our channel to stay updated. See you in the next video.